I apologize for posting this video so late. I have another video. Unfortunately, that video is not working. It says the file is corrupted. So something happened when I uploaded the video, and I don't have the original, so I'm making a new one. So we're doing some stoichiometry. These are called mold-mole problems, and basically this is a recipe. So what you guys have been doing with recipes and things like that, where I'm telling you to double and triple and quadruple and half it, we're doing the exact same thing except with a chemical reaction, which is really just a fancy looking recipe. Just to give you an idea, so here we have N2, and there's no number, so it's just one of these. Added to 3H2s is going to give you 2 NH3s. This is balanced, right? So if you guys remember balancing, I know, brings back some bad memories. But the N's are the same, the H is the same on both sides. So these reactions will already be balanced for you, so you don't have to do that. So let's look at the problem. How many moles of hydrogen, and I'm actually going to highlight this as we do this, how many moles of hydrogen are needed to completely react with 2 moles of nitrogen? So right now we have 1 mole of nitrogen and 3 hydrogens. What I want to know is how much hydrogen am I going to need if I change this to 2? Now this might seem really easy to do in your head, and a lot of you guys can do these ones that I'm getting in your head. But I am still going to show you how to do them the correct way anyways, just because. So I have 1 N2 right now, and that is for every 3 H2s. So for every 3 hydrogen molecules here, H2s, I have 1 nitrogen, right? It's a 1-to-3 ratio, or 1/3, right? Now, what I'm telling you is if I change this number to 2, right, how many hydrogens am I going to have? I'm going to make that a question mark. Okay. Wow, I'm really getting good at writing with this pen. Woohoo, finally, right? Just took me like 4 months. All right, so to do this, there's a couple ways to do it, but I'm going to show you the cross multiplication. And the reason we're going to do it that way is because if this was a decimal, it would be really tricky to do it the other ways. So what I do is you cross multiply like you would in math and solve for this question mark, which we're going to mark as x, okay? So if I cross multiply this way and this way, what I get is I get 1x equals 6. Now when I cross multiply, I don't need to worry about the n's and the h's and things like that. I know I'm solving for h anyway, right? Because it's asking me for that. When you cross multiply, just look at the numbers. That's going to help a lot. So I get 1x equals 6. Now, obviously, if I divide both sides by 1, I get 6 as my answer. So it would be 6 moles of hydrogen. And I'm going to actually put moles of H2 on there so I know which molecule I'm talking about, right? Because it's important. There's 3 different ones here. All right. Now, notice I did nothing with this guy right here. That's totally fine. You're only going to use 2 of these whenever we compare. So if there's 3 here or 4 here, you're only going to actually be using 2 of them. You're not always going to use all of them. So kind of nice. And what that really means is that if I double this, I'm going to double this too. Duh, right? It's like a recipe. If I need double the amount of nitrogen, I'm obviously going to use double the hydrogens, right? If I need to get the same results. Same thing if you're baking cookies. If you were making double the recipe and you need 2 eggs, you're going to have to now have 4 eggs. Everything is doubled, right? Does that kind of make sense? Okay, I hope so. Okay, so now I'm going to get rid of that one. Unfortunately, I can't really do a few. I'll try to do these 2 on the same screen, make it a little easier. I'm going to do the next 2. So how many moles of oxygen are produced by the decomposition of 6 moles of potassium chlorate? Now, if you're not sure which one is which, the best thing to do, honestly, is to Google this. So if you're like, oh, I don't know which one of these is potassium chlorate, just literally type potassium chlorate into Google, and it will show you that it's actually this one right here. And then I'm looking at oxygen, which is this one. So notice this guy's kind of left out here. That's okay. We don't need him. All right. No biggie. All right. I'm going to actually make this line a little thicker too so you can see a little better. All right. So these are the 2 I'm comparing. I want to know oxygen. Let's do this. So 2KClO3, which is potassium chlorate, all right, produces 3 oxygens, right? So if I break this substance down, what I'm saying is I get 3 oxygens from it, right? Now, if I have 6 of these instead of 2, how many oxygens am I going to be able to make? And we always assume that the other guy, we have enough of that part of the recipe as well, right? So how many oxygens am I going to make? I don't know, right? I'll even put the O2 here. Question mark O2, right? We don't know. That's the problem. Now again, I usually label this X because I know when you guys do this in math, we almost always use X, right? X is easy to use. So I'm going to cross multiply like I did before. And I'm actually going to show you in a different color in case that's helpful, right? So I'm going to cross multiply this way and set them equal to each other. So 2 times X is 2X, right? And then we're just going to multiply 6 times 3. We don't need to worry about the O2 in the KCl3, right? Just the numbers. So 2x equals 18, okay? Now to solve for x, I divide both sides by 2, just like you would in math. This is math, applied math. That's what you're doing. Well, math has a purpose. Who would have known, right? And then this ends up being 9. So then x is equal to 9, right? So then your answer is just 9 moles of O2. Now again, you might be saying, Baziki, really? Like I could have done that in my head, right? Obviously, if you triple this, right? This is 2 times 3 is 6. Then you triple this as well. 3 times 3 is 9. Yes, I know this. And all the ones that you're going to do for this worksheet, you can pretty much do them in your head. I just really want to show you the way that you would do them if you had to do more complicated examples. So when you take chemistry in college, which some of you will, you're going to do it a little more tricky. All right, I will do the one more of these, and then I'm going to let you guys try the last 2, okay, and see if you can figure them out. I will put the answers on there for the last 2, but I would like you to try to do the work. And you guys have been really phenomenal, seriously. So this is like the last thing we're going to do all week for the most part. Kind of cool. Okay, so, sorry, I know I talked too much. So how many moles of hydrogen are produced by the reaction 3 moles of zinc with an excess of hydrochloric acid? All right, so the one that I care about is 3 moles. Oh my goodness, that is not the highlighter. 3 moles of zinc, which is Zn. Okay. And how many moles of hydrogen, right, which is H. Now this one's really easy because notice there's no numbers, so it's just a 1-to-1 ratio, right? Like what? Yeah, it's that easy sometimes. So 1 Zn over 1 H2. And you're like, do I really need to set this up? No, probably not, right? All right, now if I have 3 Zn, how many H2 do you think I'm going to make? All right. Don't know? It's 3 because it's a 1-to-1 ratio. So if whatever number you change the zinc to, that's what you're going to change the hydrogen to. Pretty easy. So I'm not even going to do the multiplication of this one because it's just 3 H2. 3 moles of H2. I should write moles in there for you. I got to be a little more consistent, right? Sorry, I'll write really tiny. Oh, moles. Okay. Capiche? All right, so here's the deal. Try the next 2. I'm going to put the answers on there right now and then see if you can figure them out. So pause the video, try them, and then check out the answers. You guys are wonderful. I'm so proud of you for making it this far in chemistry and still working hard. I can't tell you how much it means to me. You guys are amazing. All right, so you should have paused this to try these guys, and I'm just going to give you the answers really quickly, okay? So we're looking at oxygen and propane. There's propane, okay? There's oxygen. So how many moles of oxygen need to react with 4 of this? So it's times 4. You should get 20 moles of oxygen. This says O2. Sorry, it's kind of hard to read. And then potassium nitrate and when 2 moles of potassium phosphate react with 2 moles of aluminum nitrate. All right, so here's the cool thing about this one. You could have used either one. So you have potassium phosphate, potassium nitrate's the one you're looking for, and then you have aluminum nitrate. So you could actually have used either of these to get the answer. It kind of works either way. So we'll look at potassium phosphate as this. All right. Potassium nitrate is this. Okay, so this is potassium nitrate, and then this is potassium phosphate, right? So if this is 3 and this is 1, and you double this, you should get 6 KNO3. All right. So hopefully that wasn't too bad, and have a wonderful, wonderful rest of the evening. Thanks you guys so much for working hard again. You're wonderful. Okie doke.